Hi, and welcome to today's Compressed Thought. My name's Steve Keniston, Vice President of Technology Strategy for Storwize, and what I'd like to talk to you about today is real-time compression. And I think the easiest way to describe real-time compression is to talk about what real-time compression is not, or the opposite of real-time compression. And that's traditional compression or post-process compression. The easiest way to describe post-process compression is to think about a technology like WinZip. The WinZip technology, when zipping up a file, goes through a particular process. The application is invoked. It writes out a temporary file. The larger compressed file is compressed into this temporary file. The process finishes up by renaming that compressed temporary file and then deleting the original temporary file on disk. Now the user is left with two files on their disk. So in order to continue the space savings process, that file that was compressed now must be deleted. As you can see, this is a very I/O intensive process. So it might be okay to do this for one file, but to do this for many files or a terabyte of files in a particular volume, you can understand this might be very difficult to achieve. One, has a pretty large impact on performance, and two, how would you be able to find the time to be able to do that compression? So if that operation of doing data compression post-process utilizes a lot of system resources, what will happen is you'll have to find a time when your storage array doesn't have a lot of active users on it. You'll need to be able to find a time when your snapshots are complete, when your backup is finished, and hope that you have a window of opportunity that allows you to be able to do this type of compression. In addition, once these files are compressed, they can't be seen by the application. What I mean is, let's go back to the WinZip example. If I zip up a Word document, if I take Microsoft Word and point it at this zip file, Microsoft Word doesn't understand what this zip file is supposed to be. So I can't look at the file, I can't edit the file, and that sort of thing. Right? So what I must do is I must decompress that file in order for it to be used. I thought the whole point of compression was to save disk space. If I'm decompressing files that I need to use on my array, then I'm not really saving a lot of space. Users try to work with their different lines of business managers to try to maximize this space savings. And the way they do this is they have meetings to discuss when do different lines of businesses consider their data to be stale. Once that data becomes stale, they can zip that data up, and when I need to use it, and hopefully the older the data is in its life cycle, the less chance I'll have to go and decompress that data, reduces the amount of labor that it would take to be able to actually use that information. But let's say, for example, an organization decides that every 30 days their data becomes stale and they're going to compress it. They compress a large volume. They compress a lot of files into one large zip file. Now let's say I decide that at the end of the quarter I need to use that capacity. I actually need to unzip or decompress all of that data onto my disk in order to use it. Or, even worse, if I only need one of those files, finding that file without a good data management system could be very time consuming, and I may not even be able to find that file. So you can see traditional compression or traditional post-process compression, right, kind of saves some disk space but not really, isn't very transparent to the application, right, and can be very costly from a performance perspective and as well as a labor perspective. So, and anytime a human has to get involved with uncompressing or decompressing data in order for it to be used, we all know from the backup world, if I have to go recover data from a tape, it can take a long time for that information to be accessible. Right? The opposite of post-process compression is real-time compression. And that's what the Storwize technology is really all about. Storwize's intellectual property is not wrapped around compression. We leverage industry standard compression algorithms, LZ compression, but we take it one step further. Our intellectual property takes traditional compression algorithms that customers are very familiar with. They give you the most bang for your buck from a compression ratio standpoint, but we focus on how do we make that compression real time. And the way we make that technology real time is by putting our secret sauce in an appliance that actually sits in front of your storage array. And by doing this, right, we're able to reduce the performance impact such that there is no performance degradation, and in a number of cases there's a performance increase, that you don't have to decompress data on the array in order to use that data. And we do this by being fully transparent to the application when we're installed in the data path. So by doing compression before you actually get to the storage array, you actually can increase the performance, which is the biggest consideration you need to think about when doing compression within your storage. So by compressing data before it gets to the array, if we take a look at the lowest common denominator in the array, or the slowest moving part, it's still the mechanical disk arm of the disk. So if I'm storing less data, I'm moving that disk arm less, thereby reducing the amount of I/O, right? Increasing the number of CPU cycles that I can use during the same given amount of period of time. I'm actually gaining performance. In addition, whatever my compression ratio is on disk, let's say 2:1, what I end up getting for my cache is a 2 times bigger cache hit capacity, or a 2 times larger cache, so that I get better cache hits when doing I/O. And if cache is king in your storage array, and typically the most expensive component in your array is your storage cache, right? You've doubled that amount of cache, thereby giving you an increase in performance. So you have increased cache, lower disk I/O, higher storage CPU utilization, or lower utilization, giving you more processing power to do more work on your storage. You have no performance degradation, or in many cases an increase in performance. In addition, the way Storwize writes the file out to the disk, we preserve the transparency, or we preserve the file envelope of that file, so it's transparent to the application. So now if I'm Microsoft Word and I look at a Storwize compressed file, I actually have the ability to recover that file or retrieve that file and use that file without doing any decompression on disk, thereby saving my disk capacity. So with Storwize, compression equals compression. I don't need excess capacity on my disk to decompress files in order to use them. I'm transparent to my storage, to my networks, and to my application, and I have no performance degradation. So if you're looking to reduce your capital expenditures on storage, as well as reduce your operational expenditures on downstream processes such as backup, replication, and archive, take a look at the Storwize technology at www.storwize.com. Thank you. I'm Steve Kenniston, and that's today's Compressed Thought.